Hello friends, welcome to Civil Engineering exam. Today we are going to see the topic related with design of reinforced concrete structures in the topic of curtailment. So the curtailment in the beam. So the curtailment is the shortening or termination of the rebars wherever that is not required. So in the RCC design we have to consider the economical design. So wherever the steel reinforcement is not required that much, so now in order to reduce the steel reinforcement we can curtail the steel bars, so that is called curtailment. Okay, so the location where the tensile reinforcement bars can be terminated without compromising the structural integrity, so that is called curtailment point. Okay, so now why we have to curtail the reinforcement? So the first thing is we can make the economical reinforced section. Okay, so wherever the steel is required, so the tensile reinforcement is required, so we can provide enough reinforcement. Okay, so if case we don't want that resist the bending moment in that place, so now we can reduce the steel reinforcement. Okay, so now we can take the example of simply supported beam. So in that simply supported beam with the uniform loading, the maximum bending moment occurs at the center of the span. So the tensile steel required is 100% in the center. So it can be reduced in the supports, because in the supports the bending moment will be the zero. So now we can reduce the tensile reinforcement in the supports. Okay, but we have to ensure the bond strength. Okay, so in the design consideration, so we have to ensure the bond between the concrete and as well as the steel. Okay, so if case the slipping is will be happen, so now we can consider the bond strength also, so without affecting the structural integrity. So now we can reduce the steel reinforcement, that is called curtailment. So IS 456 provides a specific guidelines and requirement for the curtailment of the reinforcement. So based on the IS 456, we can see the problem. So where we can curtail the reinforcement in the with the live example. Okay. So in that video, we can see the one solved problem where we can cut the reinforcement. So the theoretical cutoff point as well as physical cutoff point. So everything we can find out using the solved example. Okay. So now the example problem, a reinforced concrete beam 6 meter span is uniformly loaded and the reinforced with 5 bars of 20 dia on the tensile side at the effective depth of 400 Okay, so find the distance from the center of the beam where one of the bars can be curtailed. Okay, so adapt M20 grade concrete and Fe415 HYSD bars. Okay, so now the given value, so L is given, the length of span is 6 meter. Okay, so then that is equal to 6000 Okay, so next effective depth D equal to 400 So then FCK is given, FCK is 20 Newton per square. So that is M20 grade concrete. Then Fy is 415 Newton per square. So then diameter of the bars is given, dia is 20 is tau BD. So tau BD equal to 1.6 into 1.2, that is equal to 1.92 Newton per square. So now AST will be 5 numbers of 20 dia bar, so pi by 4 into 20 square. Okay, so now we can find out the theoretical cutoff point from the bending moment consideration. So first thing is theoretical cutoff point, so TCP in the consideration of bending moment. So now x is the distance between the cutoff point measured from the center of span. So now we can take the x. So now we can take W L square by 8 minus W x square divided by 2 divided by W L square by 8, that is equal to 4 divided by 5. Okay, so now we can take x equal to 1.34 meter, so that is equal to 1340 So now we can find out the development length for the maximum tension at the center of H415 HYSD steel bars. So now we can take the development length. So now LD equal to 5 into sigma S divided by 4 into tau BD. Okay, so these are all come under the IS 456. So now we can take 5 is 20 mm into sigma S equal to 0.87 into Fy, that is 0.87 into Fy value is 415 divided by 4 into tau BD. So tau BD is 1.92. Okay, so solving this we got the value of 940 mm. So now we can find out the physical cutoff point, that is equal to TCP plus D, or 12 into 5. Okay, so now we can substitute TCP value. So TCP is 1340 plus D is 400, or 12 into 20. So now we can take 1740 or 240. Okay, so now we can take whichever is higher. So the 1740 mm is the higher value. So now physical cutoff point will be 1740 mm, or we can take 1.74 meter. Okay, so this is a method we can solve the problem. Again, we will see next video. Thank you.